Assalamu alaikum. So after doing all the topics from coordinate geometry, topics including the distance formula, the midpoint formula, the equation, the line equation, then we have the perpendicular and the parallel lines. So we know all these concepts. So after that, let's start the past papers. The first question that I have chosen is from paper 1, variant 2, October, November, year 13, and question 1. So the concepts that we shall be doing in this question are number 1, the gradient formula. Number 2, it's a rectangle. Therefore, the sides are perpendicular to each other, and also there are two sets of parallel sides. So let's start doing the question. The diagram shows a rectangle. So the first thing that I know is that we will be dealing with a rectangle ABCD. So the properties of rectangle are, number 1, if the rectangle is given to us, then we know that there are two pairs of parallel sides. We have these two pairs of parallel sides, and we know that for parallel sides the gradient will remain the same. So let's call this gradient m1 and let's call the other gradient as m2. Number 2, the rectangle, they are perpendicular to each other. Therefore, the two gradients are going to be negative inverses of each other. We know that it's m1 times m2, which is equals to negative 1. So this is what we know about a rectangle. Then point A is given with coordinates 0, 8. Point B is given with coordinates 4, 0. A lies on the y-axis because the x-coordinate is 0. B lies on the x-axis as the y-coordinate is 0. So the diagonal AC has equation. This is the diagonal AC with equation 8y plus x equals 64. So we need to find by calculation the coordinates of C and coordinates of D here. So with respect to AB, A coordinate is 0 and 8 and B coordinates are 4, 0. So we have discussed that being a rectangle, the sides are perpendicular. Therefore, whatever is the gradient of AB times the gradient of BC, that needs to be a negative 1 here. The other thing that we can notice is that we have BC and we have AC, where C is the common point, and if C is the common point, then equation of BC and equation of AC can be compared or solved simultaneously to get the coordinates of C. So this is the mind mapping that we should be doing before starting the question. So let's first get the gradient value. The gradient of AB, as I can see here, that AB, the line AB is making a right triangle with respect to the origin. I can see that the rise here is equal to 8 and the run with respect to the origin is a 4. Therefore, the gradient value here we can say is going to be the gradient of AB. It's the line which is sloping down. Therefore, I'll write it with the negative sign. It's rise over run. So I can simply say that this gradient is going to be negative 8 divided by 4, which is equals to negative 2. Therefore, AB being perpendicular to BC, I can say that the gradient of BC needs to be negative inverse of the gradient of AB. Or in other words, I can say that if the gradient of AB is a negative 2, if the gradient of AB is a negative 2, then obviously for BC, the gradient should be having the opposite sign, which is a positive, and then it should be 1 over 2 here. So I have the gradient of BC, and to get the equation of BC, we had the line BC where the coordinates of B were 4, 0. We got the gradient of BC, which is a 1 by 2. So I can very easily get the equation of BC by saying it's y minus y1, which is equals to the gradient times x minus x1. So substituting the coordinates of B, I shall say it's y minus 0, which is equals to 1 by 2 times x minus 4, or I can say it's 1 by 2x and a negative 4 by 2, which gives me a 2. This is going to be the equation of BC. So as discussed earlier, equation of BC and equation of AC, they need to be compared or solved simultaneously. Equation of AC is 8y plus x equals 64. Equation of AC is 8y plus x equals 64. So solving these two equations simultaneously, I can say here that this y coordinate then is going to be 64 minus x, and I can say it's 64 divided by 8 minus 1 by 8x, or I can say that this is going to be 8 minus 1 by 8x. So this is going to be the equation of AC where y is the subject. Solving equation of AB and BC, let's call this equation 1 and this equation as 2. Solving the two simultaneously, I can say it is 1 by 2x minus 2, which should be equal to 8 minus 1 by 8x. Or it's 1 by 2x plus 1 by 8x, that should be equal to 8 plus 2, or solving it, I can say that this is 1 times 4 divided by 2 times 4x plus 1 by 8x, which is equals to a 10, or 8 being the LCM, it's going to be 4 plus 1, that's a 5, which is equals to 10. Or I can say that x is equals to 8 into 10 divided by 5, or x will be equal to 16. So I have the x coordinate of C, which is going to be a 16. Now to find my y, I can just substitute this in any of the equations. If I substitute this in equation 2, which says it's y which is equals to 8 minus 1 by 8x, substituting this x value here, this becomes 8 minus 1 by 8x into 16, or I can say that this is going to be 6. Therefore, I have the C coordinates, the x coordinate is a 16 and the y coordinate is a 6. So I have calculated the coordinate for C, which is 16 comma 6 here. So to find the D coordinate, I already have the C coordinate. To find the D coordinate, C is 16 comma 6. I can compare the distances between A and B. I know that for AB, it's the horizontal distance which can be represented as a 4, and the vertical distance, it's the horizontal distance which is equals to a 4, and the vertical distance which is equal to an 8. So even if I go for DC, I should know that the horizontal distance, being a rectangle, should be equal to a 4, and the vertical distance for DC, that should be equal to an 8. So to get the coordinates there, I am just writing it in the column matrix form, so that I should say that it is 4 and 8. And so to find the distance DC, I am using the column vector form. The line was sloping down from A to B. Therefore, I can say that the y distance or the rise is a negative 8, and for DC the horizontal distance was a 4. So DC then will be equal to OC minus OD. Equation is 4, negative 8, which is equals to the position vectors of C, which is 16 and a 6, minus XD and YD. Or I can say this is XD, the X and Y coordinates of D, that will be equal to 16 minus 4 and a 6 plus 8. Or I can say that the D will be having coordinates which are 12 and a 14. So I do have the coordinates of D also, which is 12 comma 14. So that is going to be my answer for for the coordinates of D here. The second question that we are going to practice today is from May-June 2013, and it's variant 3, question number 7. So this question is of 8 marks, and let's start working on it. The diagram shows the points A, 2 and 14. We have the coordinate of A, which is 2, 14, and B, which is 14, 6, and we have been given 7 also, which is 7, and C also, which is 7, 2. The point X lies on AB. So X is on AB and CX is perpendicular to AB. So if CX is perpendicular to AB, so this information is very important to us, because if we know that to the line AB there is a perpendicular which is CX, then I should know that the gradient product of AB is going to be equal to a -1. So there is mind mapping here, that if the coordinates of A and B are given, very easily we can get the coordinates of AB. That means I should be getting the gradient of the line CX, the perpendicular CX. So find by calculation the coordinate of X. So we are supposed to get the coordinates of X here. So to get the coordinate of X, let's do the mind mapping again. We have to have the gradient of AB. We are doing part 1, where part 1 says find the coordinates of X. We are supposed to find the coordinates of X here. So gradient of AB will be equal to the difference, the vertical difference between A and B divided by the horizontal distance between A and B. So this I should say is equals to 6 minus 14 divided by 14 minus 2. That will give me a -8 divided by 12, or in other words I can say that this gradient is a -2 by 3. So since AB and CX, they are perpendicular to each other. They are perpendicular to each other. So I should know that if the gradient of AB is equals to a -2 by 3, then gradient of CX should be equal to a +3 by 2. It has to be the negative inverse. So I can have the gradient of CX, which is equals to a 3 by 2 here. I have the coordinates of C, 7, 2. So that means very easily I can get the equation of Cx, and I have the gradients of A and B also. Like if I take the gradient of A, which is 2 and 14, I can get the equation of AB also. And then if I solve the two equations for AB and Cx, equations of AB and Cx simultaneously, I should be getting the coordinates of X here. So let's start finding the equation of AB and then the equation of Cx. So equation of AB, so to find the equation of AB, I'm using my coordinates of A, which are 2 and 14, and also the gradient value of AB, which is a -2 by 3. I know that the equation is represented by y minus y1 equals gradient times x minus x1. So if I substitute the values of y1, which is a 14, the gradient, which is a -2 by 3, and I'll be left with x minus 2 here. So getting the equation in terms of y, I should say it's a -2 by 3x, +4 by 3, and then -14 taken to the right side will become a +14. So that means that equation of AB is going to be -2 by 3x plus 3 14s, that's a 42, and 42 plus 4, that will give me a 46 divided by 3. So this is going to be the equation of AB. So this is my equation of AB here. In the same manner, I will be getting the equation of AC. So to get the equation, sorry, not AC, equation of Cx. So in the same manner, getting the equation of Cx, I have the coordinates of C, which are 7, 2. I have the gradient of C as well. It's a 3 by 2. So again, I have y minus y1, which is equals to gradient times x minus x1. For y1, x1, I will be substituting the C coordinates. Therefore, I can say it's a y minus 2, which is equals to 3 by 2 and x minus 7. So getting the equation in terms of y, I can say it's a 3 by 2x minus 3 times 7, that gives me a 21 by 2, negative 2 taken to the other side, that gives me a plus 2. Or I can say that this equation comes out to be a 3 by 2x and a negative 21 minus 4, that will give me a 17 by 2 here. So this is going to be the equation of Cx. I can just solve the two equations, the line equation of AB and Cx, simultaneously to get the coordinates of x. That means I should be equating both the equations. So my negative 2 by 3x plus 46 by 3 is equals to 3 by 2x minus 17 by 2. Or I can say it's a negative 2 by 3x. Just take the x on the left side and the constants on the other. So minus 17 by 2 minus 46 by 3. So this becomes a negative 4x and a negative 9x divided by 6. And this will be equal to a negative 51, negative 2, 6 are 12 and 8, and then negative 92 divided by a 6 again. The 6 on both the sides get cancelled. I will be left here with a negative 13x, which equals negative and 143, negative 143. The negative gets eliminated and x will be equal to 143 divided by 13, which will be equal to an 11. So x then will be equal to 11, meaning the x coordinate of the point x is going to be 11. To find the y coordinate, just substitute this in any of the two equations of AB or Cx, so that if I substitute this x in the equation of Cx, this was 3 by 2x minus 17 by 2. Substitute, and this is 3 by 2 times 11 minus 17 by 2, and that is going to give me a 33 minus 17 divided by 2. So this will be giving me a 6, and 16 divided by 2, which is an 8. Therefore, I can say that the x coordinate of x is an 11 and the y coordinate here is an 8. Therefore, x will be having coordinates as 11, 8. So this shall be the answer for part 1 here. Now solving for part 2. Solving for part 2, the question says, we are done with part 1. Part 2, the question says, get the ratio for AX is to XB. Get the ratio for AX is to XB. Now to get this ratio, we have the coordinates of x, which are 11 by 8. I would suggest to get either their vertical distances or the horizontal distances between xb and xa. So to do that, if I get the vertical distance, I can say that the vertical distance for AX is 14 minus 8, which will be equal to a 6. And the vertical distance between XB is going to be 8 minus 6, which is equals to 2. So it's just a 2 marks question, so not very lengthy working should be required. I have just taken their vertical distances. The vertical distance between AX is a 6. And the vertical distance between XB is a 2. So I can say that they are in the ratio of 3:1. If you wanted to take the horizontal distance, then even with that working, you should be getting the same answer. If I compare their horizontal distance, so for horizontal distance, what I know is that the horizontal distance between A and X is going to be 8 minus 2, it's going to be 11. The horizontal distance is going to be 11 minus 2, which gives you a 9. And the horizontal distance between B and X is going to be 14 minus 11, which will give you a 3. So comparing the two, I can say that the horizontal distance is also in the ratio, which is 9 divided by 3, which again comes out to be 3:1. So either way, you can just calculate the ratio of the distances between AX and AB, and 3:1 is going to be the answer. So you can choose either of the distances, horizontal and vertical, and get their respected ratio. So this is now question number 3 for us, which is from May, June, variant 3 and year 14, and this is question number 11. So it's a 9-mark question, so obviously it is a very heavy question and needs to be done with a lot of care to get all the marks here. So here in the question they are saying it's a parallelogram ABCD. So here we are expected to know the properties of parallelogram. So ABCD, it's a parallelogram. So obviously for a parallelogram we know that AB shall be parallel to CD, and in the same manner it should be BC parallel to AD. So we have to be very careful with the directions. AB parallel to DC and BC parallel to AD. And then we should also say that the gradients here, like this is just a mind mapping that we are doing here, which says we should know that the gradient of AB shall be equal to the gradient of DC, and the gradient of BC shall be equal to the gradient of AD. So this is the mind mapping that we have done up till now. So, and then they are saying that the equation of AD is x plus 11. So let's take the data. Equation of AD is 4y. Equation of AD is 4y, which equals x plus 11. And they have also given us the equation of AB, which is equals to y equals 3x. And the diagonals AC and BD, they meet at the point E. So we have the information about the diagonal meeting at point E with coordinates 6.5 and 8.5 here. Or we can also say that this equals a 13/2 or a 17/2 in fractions. So find by calculation the coordinates of A, B, C, and D. Alright, so to find the coordinates of A, B, C, and D, what I know is that if I just look at the equation, which is y equals 3x, I can see that the gradient of AB is a 3. Therefore, the gradient of CD is also going to be 3. If I look at AD, from here I can say that the gradient, if I just bring it to the form of y equals mx plus c, then I know that the equation can be written in the form as y equals 1/4x plus 11/4, meaning the gradient of AD is equals to a 1/4, which means the gradient of BC also needs to be a 1/4 here. So let's write the data here properly. So it's the gradient of AB, which is equals to the gradient of DC, and this comes out to be a 3. And we have the gradient of AD, which is equals to the gradient of BC, and this is equals to a 1/4 here. All right. So the other thing that we know is that the line AB and the line AD, they are meeting at point A, meaning I can equate and I should equate both the equations of line equations of AB and AD, solve them simultaneously to get the coordinates of A. This is a very clear hint to us. We should be getting the coordinates of A by solving the line equation AB and AD simultaneously. So equation of AB and AD simultaneously is equal to 4y, which is equals to x plus 11. Therefore, we have already brought it to the form. This was the equation of AD. So it's a 1 by 4x plus 11 by 4. Equation of AB was given. It was y equals 3x. I will be equating both of them simultaneously to get the equation, to get the x coordinate of A. So 1 by 4x plus 11 by 4, which will be equal to 3x. Or I can say this is x plus 11, which is equals to 4 times 3x. Or x plus 11, which is equals to a 12x. Or I can say it's 11, which is equals to 12x minus x, giving me an x. Or x for A is going to be a 1 here. So if x for A is a 1, then y equals 3x. Therefore, the y coordinate of A is going to be 3 times 1, which is a 3. Meaning I have the coordinate of A, which is 1 comma 3 here. So this is one information that we have gotten with respect to the coordinates of A. Now, if I look at the diagram, here, then for this diagram, what I know is that I have calculated A. Now, A is, let's write the A coordinates here. The A coordinates are 1 comma 3. So if E is the meeting point of the two diagonals, then that means E has to be the midpoint of AC. E is the midpoint of AC. E is the midpoint of AC and also for BD. This is the property of parallelogram. So if E is the midpoint of AC, I can use the midpoint formula, which says that the midpoint for E x shall be equal to the x coordinate of C and the x coordinate of A divided by 2. In the same manner, I can say that if it is the midpoint of E, the y coordinate, then it should be the y coordinate of C and y coordinate of A and divided by 2 here. So I have been given E and E is, the x coordinate of E is 13 by 2, which shall be equal to xc plus 1, which is the x coordinate of A divided by 2. So the 2 gets cancelled and I will be left with the x coordinate of C, which is going to be 13 minus 1, that is a 12 here. In the same manner, I can get the y coordinate also, and for that the y coordinate for E is a 17 by 2, which is equals to the y coordinate of C, and then AY coordinate, which is a 3, and this also gets divided by 2. The 2 gets cancelled and I will be left with the y coordinate of C, which is 17 minus 3, that is going to be a 14. So I have the y coordinate as well as the x coordinate of C also. So C will be having the coordinates as 12 and 14. So now B and D are left. So to get B and D, let's write the coordinate of C on this, which is a 12 and 14. All right. Now to get the coordinate of B or the coordinate of D, what I can do is, I know that B is the common point for BC as well as for AB. So B being the common point for AB, the intersection point for AB and BC. I have for the line equation AB, if I solve for the line equation AB, I know the gradient. The gradient for AB is equals to, in fact, for the line AB, I have the line equation, which is y equals 3x. Y equals 3x. For BC, I can make the line equation, and I can say that for the line equation, the C coordinates are 12 and a 14, and the gradient is a 1 by 4. So with respect to this, I can just have the line equation for BC, and I can say it's y minus 14, which is equals to 1 by 4 and x minus 12. Or I can say that BC has the line equation, which is 1 by 4x minus 12 divided by 4 and a plus 14, negative 14 from left hand side taken to the right side. So this becomes a 1 by 4x and 14 minus 3, that will give you a positive 11. So this is now the equation of BC. Now BC and AB, they are intersecting at point B. Therefore, I can equate the two equations, and if I do that, I'll say it's 3x, which is equals to 1 by 4x and a plus 11. Solving it, it should be 3x minus 1 by 4x, which is equals to 11. Or I can say this is 11 by 4x, which is equal to 11. 11 on both the sides gets simplified, and I will be left with x, which is equal to a 4. So I have the x coordinate of B. So the y coordinate is going to be very simple. It should be 3 times x, or I can say this is 3 times 4, or this becomes a 12 here. That means I have the y coordinate also, which is a 12, and very easily now I have the coordinates of B, which are 4, 12. So B is also done. Now the only point which is left is point D. So again, if I look at the diagram, I can see that E is the midpoint of BD also. So E is the midpoint of BD. Therefore, we'll be using the midpoint formula again, and I'll say it's the midpoint of E x coordinate, that should be equal to the x coordinate of B plus the x coordinate of D divided by 2. And also I will be comparing the midpoint y coordinate, which should be equal to YB plus YD divided by 2. So the midpoint x coordinate E is a 13 by 2. That should be equal to the x coordinate of B and x coordinate of D divided by 2. The 2 gets cancelled, and I can say that the dx coordinate is going to be 13 minus 4, which is going to be just an 11, just a 9. And then substituting the y coordinates, it's 19 by 2. This will be equal to the y coordinate of B, which is a 12, plus D divided by 2. The 2 gets simplified. I will be left with 19 minus 12, which will give me a 7. Sorry, not a 19. It should have been a 17 here. So it's a 17 minus 12. That would give me a 5, and that is going to be the y coordinate of D then. So D will be having the coordinates as 9 and a 5. So just writing all the coordinates of A, B, C, and D, I can say that A was having the coordinates which were 1, 3. B was having the coordinates as 4, 12. C was having the coordinates as 12, 14, and D was having the coordinate as 9, 5, and this is going to be the answer. Let's do another question, and this one is from variant 2, October, November, year 2016, and this is question 5 of 6 marks. Now, let's read the question. It says it is x by a plus y by b. This is equals to 1. A, b are positive constants. A and b, they are positive constants. They intersect the x and y axes. Now let's start underlining the keywords. They are intersecting the x and y axes at the points A and B respectively. So there is one thing which is very much clear. A is on the x-axis. So if it lies on the x-axis, then I know that it should be having the y-coordinate as a 0. So this is xa, 0. And B is on the y-axis. So if it lies on the y-axis, then the x-coordinate needs to be a 0 and it should be having a certain y-coordinate. And the midpoint of AB, the other information that we have says midpoint of AB lies on the line 2x plus y equals 10 and the distance AB is equal to 10. So these are the informations that we have with the help of which we are supposed to get the values of A and B. So the midpoint of AB. So the first thing here is to get the coordinates of A and B. We know A lies on the x-axis and also x by A plus y by B was equal to 1. And if that was the case, then it was very much clear that this line was intersecting the x-axis at A and the y-axis at B. So if I substitute y for 0 to get my A coordinates, I will be substituting for A, it's y, which is equals to 0. So that means it's x by A plus 0 and this is equals to 1. And I can say that the x coordinate of A will be equal to A here. This is the x coordinate of A. And in the same manner, if I solve for B, then for B I know that it lies on the y-axis, therefore the x-coordinate is a 0, and if in the equation I substitute x as 0, it becomes 0 plus y by b, and this is equals to 1. Therefore y by b will be equal to 1, or I can say that the y-coordinate of b comes out to be a b here. So this is one thing that is very much known to me. And also, if I rearrange the equation x by a plus y by b, which is equals to 1, with the help of the information that we have, which said that a and b are positive constants, I rearranging them, it's y by b was equal to negative x by a, which is equals to 1, or I can say that the line was actually having the gradient as negative b by ax plus b here. So the gradient of the line is a negative b by a also. So this is one information that we have. So this means that if I draw the line AB, then basically it was the x-axis and the y-axis where the line with was having a negative gradient, therefore it was a sloping down line with A as coordinates, with B as coordinates 0, b, and A as coordinates a, 0, and the gradient of this line is a negative b by a here. So this is the information that we have up till now. The next information that was given was regarding the midpoint, which says that the midpoint of AB lies on the line 2x plus y equals 10. So midpoint of AB, that means it's this coordinate here. So if I get the midpoint of AB with the coordinates that I have, I can say that the x coordinate here has to be a plus 0 divided by 2, and it should be 0 plus b divided by 2. So the midpoint here for AB is a divided by 2 and a b divided by 2 here. So this midpoint, it says, was passing through the line which was 2x plus y equals 10. So 2x, let's have the question here. So this midpoint, which we just found as a by 2 and b by 2, is passing through the line which is 2x plus y equals 10. So if it's passing through the line 2x plus y equals 10, I know that its x coordinate is a by 2. So I'm just going to substitute a with respect to a by 2 and y with respect to b by 2, and this is equals to 10, so that at least I should have an equation which is a plus b by 2 that equals to 10. Or I can say that it is 2a plus b divided by 2, which equals 10, or 2a plus b, which is equals to a 20, or I can say it's b, which is equals to 20 minus 2a. So from here, at least I can get b in terms of a, which is equals to 20 minus 2a. So this is a in terms of b with respect to the information which says that the midpoint of AB lies on the line 2x plus y equals to 10. And then they are saying that the distance AB is equal to 10. So this is another information that is given in the question. They are saying that the magnitude of AB equals 10 here. So for the magnitude, we know that AB, the magnitude should be represented as under root xb minus xa the whole square plus yb minus ya the whole square. So I did have the coordinates of a, I did have the coordinates of b. The coordinate of a, if I just go back, I can see that the coordinate of a was a comma 0, that the coordinate of a was a comma 0 and the coordinate of b was 0 comma b. And I've also given the distance of AB. So substituting these values, I can say it's 10, which is equals to under root xb minus xa, meaning it's a 0 minus a the whole square, plus yb minus ya, meaning b minus 0 the whole square. So to eliminate the under root, I should square both the sides. And if I square both the sides, obviously the under root sign gets eliminated. 10 square gives me 100, which I will be left with 0 minus a the whole square, which is just a square, and b minus 0 the whole square, which is just b square here. So now I have the second equation in terms of a and b. So this is the second equation which I have in terms of a and b here. So that means if from the first information with respect to the midpoint, I had b which is equals to 20 minus 2a. So I can substitute that in the second equation. So I'll just say substitute b equals 20 minus 2a in equation 2. I can say it's 100, which is equals to a square plus 20 minus 2a the whole square. The entire equation is in terms of a. That means I should be able to get the a value here. So 100 will be equal to a square plus, now this is again just for the reminder, a 20 minus 2a the whole square is following the identity, which is x minus y the whole square, that is x square minus 2xy and plus y square. So I am just going to write here 20 the whole square minus 2 times 20 times 2a and plus 2a the whole square. So 100 will be then equal to a square plus 20 square, which is a 400, minus 2 into 20, that's a 40, 40 into 2, that gives me an 80a plus 4a square. Or I can say it's 100, which is equals to a square plus 4a square, a square plus 4a square, that will give me a 5a square minus 80a and a plus 400. So 5a square minus 80a plus 400 minus 100 is equal to a 0. If I do the sixth question on the topic from May-June 2017, variant 3 and question 8. So let's see what the question says. We are given point A, which is negative 1 and 1. There is a point B, which is having the coordinates as A and B are the constants for this question. The gradient of AP, they have given us the information for the gradient. This is a 2. So find an expression for B in terms of A. So this part 1 is not going to be difficult. They have given us the gradient of AP, and we know that this should be a YP minus YA divided by xp minus xa. Substituting the values, it's 2, which will be equal to b minus 1 divided by a minus minus 1, which we should say is a b minus 1 divided by a plus 1. So here I can say that it is 2 times a plus 1, which is equals to b minus 1, or 2a plus 2, and this equals b minus 1, or 2a plus 2 and a plus 1 is equals to b, or I can say that b is equal to 2a plus 3. So this is b in terms of a, which was required in the question. So that is the answer for the first part. The second part of the question says b has the coordinates. For the second part, let's take the information. B has the coordinates, which is 10 comma negative 1, is a third point. Now now B 10 comma minus 1 is a third point such that AP is equals to AB. So AP is equal to AB. Calculate the coordinates of the possible positions of B. Now they are talking about the distances here. So if they are talking about the distances, what we know is that A has coordinate, which was negative 1 and 1, and P was having coordinates which were A and B, and there is a third point B, which is 10 and negative 1, and they are saying that AP is equals to AB. So if AP is equals to AB, then we are basically talking about the distances, so that I can say this is under root xp minus xa the whole square plus yp minus ya the whole square, and this equals under root xb minus xa the whole square plus yb minus ya the whole square. So on both the sides we can see the under root sign, which can get eliminated here. Xp minus xa the whole square, I can substitute the values and I can say it's b minus 1, and this is the whole square, plus yp, the y coordinate of p is a b, and the x coordinate of and the y coordinate of a is a 1, so it's b minus 1 the whole square. xb is a 10 minus minus 1 the whole square plus negative 1, and ya is also having a negative positive 1, therefore this becomes a negative 1 the whole square here. So solving it as b plus 1 the whole square plus b minus 1 the whole square so so substituting the coordinates for p as AB, I can, and A as negative 1 and 1 and B as 10 comma negative 1, I can get the equation which is A negative negative 1 the whole square plus B minus 1 the whole square, which is equals to 10 negative negative 1 the whole square and plus minus 1 and minus 1 the whole square. So after that, it's a plus 1 the whole square plus b minus 1 the whole square, which then will be equal to 10 plus 1, which gives me an 11 the whole square, and negative 1 and negative 1 gives me a negative 2 the whole square, which should give me a positive 4, because we know when a negative gets squared, the answer becomes a positive. Now here there is one thing that we should be very careful about, and that is that we are getting a plus 1 the whole square and b minus 1 the whole square. So do not forget that we have the algebraic identity, which can be x plus y or x minus y the whole square as x square plus 2xy plus y square, or x squared minus 2xy plus y square. So just remember that you have to substitute those identities here. But before that, we are getting A, we are getting B, and from part 1 we have already seen that B was equal to 2A plus 3. So from part 1 there was one information that we had, and that was that B was equal to 2A plus 3. So I can substitute that B here in the equation to get everything in terms of A and then get the value of A here. So this is A plus 1 the whole square plus b can be substituted as 2a plus 3 minus 1 the whole square, and this can be equal to 11 square, which is a 121, plus negative 2 the whole square, that is a positive 4 here. So this is a plus 1 the whole square plus 2a plus 2 the whole square, and this is equals to 125. So applying a plus b the whole square identity, this becomes a square plus 2a plus 1, and this becomes 2a the whole square, which will give you a 4a square plus 2 times 2a times 2 plus 2 the whole square, that gives me a 4. I'm taking this 125 on the left side, making it a negative 125, which comes out to be a 0. Now a square plus 4a square, this can be solved as a 5a square. So it's a 5a square plus 2a plus 1 plus 8a and 4 minus 125, that can be a negative 121, which is equals to 0. So my final quadratic equation becomes 5a square plus 10a and a negative 120, which is equals to 0. Solving it further, taking 5 common, simplifying the equation, this is a square plus 2a minus 120 divided by 5. So that is going to be a 24, which is equal to 0. So solving the quadratic equation, I can say it is a square plus 2a minus 24, which equals a 0. Therefore, my answer is going to be My answer for A is going to be 4 and a negative 6. So these are the two possible answers for A that I can have. A can be a 4 and A can be a negative 6 also. For B, obviously, we know that B was equal to 2A plus 3. So when A is a 4, B will come out to be 2 times 4, which is an 8 plus 3. That will give me 9, 10, 11. So B will be equal to an 11 here. And also, if I substitute B as negative 6, I can get the other value of B. So when A is a negative 6, the other value of B here is going to be 2 times negative 6, that's a negative 12. 2 times negative 6, that's a negative 12 and a plus 3. Therefore, B then is equals to a negative 12, negative 12 plus 3 giving me a negative 9. So B can have the values which is 11 and a negative 9 here. So possible values of A are 4 and a negative 6, and for B it's going to be 11 and a negative 9. So these are going to be the possible values of A and B here. So that is the solution to this question. Question which we shall be doing to get a grip on coordinate geometry is from variant 1, October-November 2018, and question 3. It says there are 2 points A and B and they have coordinates. So A will be having the coordinates as 3A and a negative A. B has the coordinate which is negative A and a 2A respectively, and again A is a positive constant. So find the equation of the line through the origin. So we are talking about the line through the origin, that means 0, 0, and it has to be parallel to AB. So if it's parallel to AB, that's the key point that we have here. It's parallel to AB, meaning the gradient needs to be the same. So if I get the gradient of AB, which should be equal to y of B minus y of A divided by x of B minus x of A, I should say that this value is 2A minus A divided by minus A and a minus 3A. So that is going to be 2A plus A divided by a minus 4A, or I can say it's a 3A by a negative 4A, and I can have the gradient value which is the gradient value as negative 3 by 4, meaning the line which is passing through the origin should also be having the gradient value which is a negative 3 by 4. The other gradient which is parallel to AB, like if I say that we have the line AB and it's such that it's the line which slopes down because we are having a negative gradient. So if it is a negative gradient here with A as 3A and a minus A and B as minus A and 2A, and there is a line parallel to it. So if it is a line parallel to it, both of them, they should be having the same gradients, which is a negative 3 by 4. So if both have the gradient which is negative 3 by 4, there is one thing more that we know, that this line, the required line, is also passing through the origin. So if it is passing through the origin, then obviously I can say that the equation of the line has to be y minus y1, which is equals to the gradient times x minus x1. Passing through the origin, y1 and x1, they need to be 0. So I can simply say that the equation of this line is y equals negative 3 by 4 x. This is how simple it was to solve part 1 here. Now the second part of the question, it says, the second part of the question says the length of AB is 3 whole 1 by 3 units. So we know what AB is. So find the value of A. So the length of AB is 3 whole 1 by 3 units, meaning I can say it's a 10 by 3. So the distance AB shall be equal to under root xb minus xa the whole square plus yb minus ya the whole square. I have the distance, which is a 10 by 3. So I can say it's a 10 by 3, which is equals to, now B coordinates. What were the B coordinates? They were also given as A and B. They were given as A as 3A and a negative A, and B was given as negative A and a 2A. So I will be substituting these coordinates here. XB, that is a minus a minus the x coordinate of a, it's a minus a minus 3a the whole square, plus yb minus ya, meaning I should say it's a 2a minus minus a the whole square. So I need to square both the sides to eliminate the square root. So the square root gets eliminated and this becomes 100 divided by 9. So that is a minus 4a the whole square plus 2a minus minus a, that gives me a 3a the whole square, or I can say it's 100 by 9, which is equals to a 16a square plus 9a square. So it's 100 by 9, which will be equal to a 25a square, or I can say it's a 25 and 100, which can be simplified to a 4. So a square will be equal to a 4 by 9, or taking square root on both the sides, I can say a is equals to a plus minus 2 by 3 here. So if a is a plus minus 2 by 3, and in the question they have said very clearly that a needs to be a positive constant, so the value of a that we should be giving here is going to be a, which is equals to 2 divided by 3. So this is going to be my final answer with respect to a being positive. So let's hope that the concepts of coordinate geometry are very well clear to everybody and there is no query left for the topic. So thank you. Thanks a lot for watching.